All right, so one more time solving this equation, or system of equations. This time we're going to solve by what's called the addition method. Okay, so this strategy kind of relies on the idea that if you have A equals B and C equals D, then what you can do is add A plus C, and that will equal B plus D. So looking at that, I hope that makes sense. A plus C, since A is the same as B and C is the same as D, A plus C is the same as B plus D. But if you look at what we did here, essentially we had two equations. We added the left sides together and we added the right sides together and produced a single equation. It kind of combines information from both of them. Okay, that's a very basic idea. We're going to use that, but we're going to use it kind of carefully in such a way that when we combine the two equations using addition, one of the variables completely cancels out. That's what we'd like to happen. So like if you had a plus x and a minus x, they would cancel each other out, and then you would be down to an equation with only one variable instead of two. That's the strategy behind this method. So with these two equations, currently if I were to add them together, let's see what we'd get. If I add them together now, x plus 2x is 3x, y plus 7y is 8y, and 10 plus 50 is 60. This is fine. This equation should be true, but it's not very helpful because nothing canceled out. Okay, so you can do that, but don't, because it doesn't help. What we want to do instead is take one of these equations and modify it in some way. So let's take the x plus y equals 10. Let's say I want to cancel my x's out completely. If I were to multiply this x by negative 2, then I'd have negative 2x, which would cancel the positive 2x when I add them. That sounds great. Let's do that. But I can't just multiply the x by negative 2. I have to multiply both sides of this equation by negative 2 and distribute that across the addition here. So I'm going to get something like negative 2x minus 2y equals negative 20. That's multiplying both sides of that equation by negative 2. Now if I look at that with the second equation, now if I add those together, negative 2x plus positive 2x cancels out. I have 0 x's, which I won't write because that's of course equal to 0, which means adding that is going to do nothing. But negative 2y plus 7y is going to give me the 5y, and here negative 20 plus 50 will give me 30. Then dividing both sides by 5, I get one of my two values, y equals 6. So this is the strategy. This is the heart of it right here. Doing something like this, which narrows it down to an equation of one variable, which you can then solve. So now that we've got one of the values for the two variables, let's substitute that 6 back into one of the equations. The simplest one to put it into would be x plus y equals 10. So instead of x plus y, I'm going to write x plus 6 equals 10. And then subtract that, and you get the other value. So again, we have the solution x is 4, y is 6. Okay, and put that back into context with the milliliters of 20% solution and the milliliters of 70% solution, and we solve the problem again in a different way. Okay, so that demonstrates the second of the two major strategies for solving systems of equations.